Hi guys, hope all of us are doing great. In this specific discussion, we're going to look at perpendicular bisectors of triangles, and this is going to be a complementary discussion on the first discussion we had on the concept of perpendicular bisectors. We say that if we have two lines I and M, and of course these are going to constitute lines which are going to run from this point of origin in the positive y and x direction and negative y and x direction given as such. We say that we can be able to describe these specific lines as line M and I, and we say that line M and I are going to be referred to as perpendicular lines if this specific point or the vertex is going to form an angle. Let's say this is from this specific point, or this is R, S, and this is point B given as such. If this specific line I is going to form a 90 degrees angle with a line M at this specific point O, then therefore we can be able to describe this specific line I as a perpendicular bisector of line M. So therefore we can be able to write this one as I is perpendicular to line M given as a notation of that specific nature. So in this particular case, then therefore we can be able to describe this specific two segments for OR and OS as equal. And from this specific case as well, we say that for a perpendicular bisector of line M, the point OS is going to be equivalent in length to point PR given as such, and that is going to form one of the characteristics of perpendiculars. This of course, this is SO, this is a segment, is equivalent to OR. So this is one of the characteristics of this specific perpendicular bisector I that is bisecting M. And then we say that the line which is or the segment still which is SP is going to be equivalent to PR, and that is another characteristic. And we say that angle P OS is equivalent to angle P OR given as such. And those are some of the characteristics of perpendicular bisectors. Now in this particular case, we're going to look at perpendicular bisectors of triangles. And we say that a triangle is a three-sided figure which is going to have this specific segment, let's say A, B, C. So this is going to constitute a segment AB, and of course a segment BC, and of course a segment CA given as such. So these are going to be three segments of a triangle given as such. So suppose we have a perpendicular bisectors for each particular segment in this specific illustration. And for AC, we're going to have a perpendicular bisector that's going to run from this specific point heading in that particular direction, and that's going to form a segment. Let's give this one O. So that's going to form segments CO and OA respectively. I hope this one is legible. Let me try to use another one. Let's see whether it's going to be consistent. So we're going to have the segment CO and OA have been given as such, and these are going to be equal. So for this particular segment AB, if we have a perpendicular bisector that is going to divide this one in two, so that's just a rough estimate. So this perpendicular bisector is going to be 90 degrees. This also is going to be 90 degrees. Let me just give a proper estimation for this. So we are going to have this one has to run at that specific point, and this is going to be 90 degrees. And then if we have this one as point P, then therefore AP is going to be equivalent to PB given as such. And then lastly, if we have another perpendicular bisector that is dividing a segment CB, this is going to be 90 degrees with that specific segment. And we're going to see that one of the characteristics is that this particular perpendicular bisectors are going to make, of course, an intersection at this specific point M. Let me describe that specific point as M. So this specific intersection is going to describe a distance that we're going to refer to as a point, which we have given as a point M. So we have said that since this triangle is made up of three segments, we are going to have three perpendicular bisectors which I've described in this particular case for AC, CB, and AB given as such, which are going to go through the same point that I've given. So in this particular case, then therefore we are going to see that every perpendicular bisector in this specific point is going to be equidistant from these two specific endpoints, and create an aspect of equidistance from these two specific endpoints, whereby we can be able to describe AM, which is going to be the distance between this one and this one. So the distance AM is equivalent to a distance CM, which are the two specific distances from these endpoints, and also which is going to be equivalent to the distance between M and B given as such. So in this particular case, then therefore, this is going to be due to the property of a transitive aspect, whereby we are going to see that the distance between this specific point and these endpoints are going to be the same from this intersection of the three perpendicular bisectors given as such. So the point that I've given as M is going to be described as a circumcenter. I'm going to give that specific name. This is going to be legible. So this specific point M is going to be described as a circumcenter. Circumcenter, this is a center. So it's going to be described as a circumcenter. And this circumcenter, of course, is going to be the point whereby all the three perpendicular bisectors are going to intersect. And of course, it's going to be the center of a circle that is going to go through these specific three vertices. So suppose we draw a circle that is going to run around, so just a rough description of a circle. This is going to be going through the three vertices, and therefore this is going to form a middle point, or the central point of that specific circle. And therefore that is going to be giving us a sense of that specific name for the circle given as such. So we can be able to say that this specific circle has been circumscribed around the triangle, and it's going to be the only circle that is going to go through these three particular vertices that I've given for this specific triangle. So therefore, in summary form, we can be able to say that this particular point M, which is a circumcenter, is going to be the intersection of these three perpendicular bisectors, and it's going to be equidistant from these three vertices for A, B, and C, as we have said. And of course, it's going to be at the center of a circle that is going to surround these three particular vertices. So this is one of the characteristics of perpendicular bisectors that we're going to encounter in triangles. And of course, as I've mentioned of the various characteristics, I hope that we are going to apply them appropriately in case we come across them in our various discussions. So that is it for now, guys. Bye. Catch us in our next video. God bless.